So looking today at differential equations, separation of variables, this corresponds to section 6.3 in the textbook. So we've seen a few of these already. Now this section we're going to work through the whole process for separation of variables. So how to get a general or specific solution, going through a pretty defined list of operations or steps to do. But of course, to start differential equations, you have to separate the variables. So get the x's with the dx's, the y's with the dy's. So in this first one, subtract x squared from both sides, negative x squared, and then get the dx over with the x squared. So multiply both sides by dx. And now you have separation of variables completed. You just now would need to go through the other steps I'll outline later. Y prime, remember y prime represents the derivative represents slope. So y prime you can replace with the dy dx. And then we're going to go ahead and separate the variables to get the x's all together to get the dx's. That was kind of a whole word salad right there. Get the x's with the dx's, y's with the dy's. So let's divide sine of x over. So I have cosine over sine, or cotangent. And then multiply dx. So dy equals cotangent x dx. Even when the problems look pretty messy, like this one, still the y prime, make that the dy dx, and start moving things over, separating variables. So we have dx in the denominator of a numerator. So multiply both sides by dx. So we have 2 dx. Oh, so I forgot the dy. Thought I was getting something. Okay. And then we have x in the numerator of the fraction on the left. So let's divide x over. Or think multiply both sides by 1 over x. The x's on the left cancel out. On the right you'll have x with dx. So dy over e to the y plus 1. It's not pretty, but the y's are with the dy's. And 2 over x dx. So in all three cases, we have separation of variables. Now let's work through a whole problem and go through all of these steps that we see. It's a pretty defined process, okay? So first, let's kind of clean this up a little bit, do separation of variables. So step 1, separation of variables. So x squared plus 4 equals times dy equals xy dx. Now on kind of two steps at once, let's divide the quantity x squared plus 4 over. Let's also divide the y over. So 1 over y dy equals x over x squared plus 4 dx. So we have our separation of variables. Step 2, would be to anti-differentiate. So antiderivative of 1 over y dy is ln absolute value y. For this question on the right, it's a pretty simple u-sub. So because x is the derivative, some form of the derivative of x squared plus 4. So let's say u equals x squared plus 4. du equals 2x dx. And du over 2x equals dx. So let's put those together. So it'd be x over u and du over 2x. The x's would cancel. Pull the 1/2 on the front. Integral of 1 over u du is gonna give you 1/2 ln absolute value of u is x squared plus 4, and plus c. So let's go ahead and put that back in. So kind of bring this over. 1/2 ln absolute value x squared plus 4 plus c. So antiderivatives like we've seen. Then step 3 is all algebra. So I want to then solve for y. And this step can be tricky algebraically. Like in this one, we have ln on both sides. So we think, how do we get rid of ln? We need to exponentiate both sides. Raise both sides and give them a base e. So e and ln on the left side going to cancel out. We just have y equals, on the right side, e to the power ln, going to move the 1/2 to an exponent on the x squared plus 4. So I'm going to get square root x squared plus 4 plus c. So all of that turned to an exponent with a base v. And then remember how exponents work, right? So if you have x to the power of 5 plus 2, that's the same as x to the 5th times x to the 2nd. Those are the same thing, okay? So if you have a summary difference in the exponent, you can break that up into a product or a quotient of two terms with the same base. So y equals e, I'll kind of take this in two steps. E to the power of ln root x squared plus 4 times e to the power of c. And of course, e and ln cancel. And e to the power of c. C is some constant. E is some constant. So a constant to a constant is just a constant. So y equals c root x squared plus 4. And we have our general solution. If you had some initial conditions or more information, you could plug those in, solve for c, find out whether c is positive or negative. Because differential equations, when you take a square root, you have to do a plus minus. But with the c in front, if we were to solve for c, we need a positive or negative value, which would handle that plus minus requirement. So take a look at the examples on the next page. Check your work with my completed notes online.